Today you're learning about inequalities. Inequalities, for your vocab, um, this symbol, just like the alligator, remember that the alligator eats the bigger number, so this symbol is greater than. So if I were to use that, for example, 6 is greater than 4, and that would be true. So another symbol you would have is greater than or equal to. For instance, 6 is greater than or equal to 4 because it is greater. So in this case it can be greater or it can be equal. So if I had 6 is greater than or equal to 6, then that is still true. So 6 is greater than or equal to 4 because it is greater, and 6 is greater than or equal to 6 because it is equal. So it can be greater or it can be equal. Both of those will work. And then we have the exact opposite. So instead of greater, we have less than symbols. So you should try and fit this in right here also. So this is less than. So the number on the left would be less than the number on the right. For example, 4 is less than 6. And we also have less than or equal to. So anytime you have, let's say now we have 4 is less than or equal to 6, but 6 is also less than or equal to 6. So we have lots of numbers that fit this. If 4 is less than or equal to 6, it could be less or it could be equal, right? And that's why the number 6 also works. There's lots and lots of answers. I could say negative 100 is less than or equal to 6. And that will also work. On here, we want to graph x is less than. That's the less than. It kind of looks like an L turned sideways, right? Less L. And you'll see the alligator is eating the bigger number. The negative 2 is the bigger number. So we want to graph this on a number line because we only have x. So we can think of this as the x-axis without the y. So we go and we find negative 2, which is right here. And at negative 2, it says that all numbers are the x, meaning our solution values are all less than negative 2, which the numbers less than negative 2 would be going this way. And then I draw my arrow. Do I want to include the number negative 2? Is negative 2 less than negative 2? And that's not true. So I would not fill in my circle saying that it is equal to it. I leave my circle open to show that it is not going to include negative 2. Another cool trick about this is because x is on the left, if you were to draw a little arrow, it shows you which direction you should head. So the next one, x is, remember this is greater than or equal to. So we find the number 3. It says greater or equal, so I'm going to shade it in because it can equal the number 3. And it's greater. Greater would be this way. So I shade that direction. All numbers that are greater or equal to 3, so that would include 4.5, 5 3/4, all numbers greater than 3 or equal. On this one, we have a picture of it and we're going to write. So we have x. Notice that it is these numbers shaded here in this direction, those are greater. So our greater symbol is this one. Because the circle is filled in, that means that this is greater or equal. It could also equal the number -4. And so in this case, this is x is greater or equal to -4. Same thing, so x, notice that it's headed this direction, and the numbers here are getting smaller, so that would include less than the number 1. And in this case, it's not filled in. We're not going to put the equal to include the number -1. Okay, so now we're going to solve inequalities. And so for this, remember we solve this just as if it were an equal sign. So if we had an equal sign here, how would I move the 8 over? Well, I'd subtract it. So the same thing is true for solving an inequality. I subtract the 8 on both sides. If you want to draw your line, you still can. And we have x. We bring down the symbol. 5 minus 8 is... Really? Sorry about that pause. 5 minus 8 is -3. So we say, if we were going to draw this on the number line, 0, 1, 2, 3. I should have, -3, so this way. So we have our -3. It is not equal to -3, but it is less than, so I should have made this side bigger. And so we would shade in the less direction. B, this one's a little bit tricky, but the negative I can either put it up or I can put it down. So I'm going to put the negative down with the -3, or down with the 3. And if this were an equal sign, the -3, right, I can move this negative down to the bottom. The -3 is dividing, so to get rid of a -3 that's dividing, I times both sides by -3, so I'm going to do that on both sides. The -3's cancel, so we have x. 9 times -3 is -27. And before I told you to just bring down the symbol, this one is a little bit different. Because I multiplied by a negative, this one's a little bit tricky, because if I bring down that symbol, then I'm saying that x is greater than or equal to -27. Well, I know the value, let's say x is 0. And let's see if that works back in our problem. If I do 0 over -3, is that greater than or equal to 9? Well, 0 divided by anything is 0. So is 0 greater than or equal to 9? And that's not true. So what's interesting about inequalities is that when you multiply or when you times by a negative, when you multiply or divide by a negative, you have to flip your sign. So in this case, what we really have, we should have x is flip the symbol the other direction. So x is less than or equal to -27. So let's see, a number less than, maybe it's -36. So let's try it. -36 over -3 is greater than or equal to 9. So I plugged it back into the this original equation. I picked a number that was less than -27. And if I divide these out, I get 12 is greater than or equal to 9. And now it works because 12 really is greater than or equal to 9. So in this case, when you multiply or divide by a negative number, you do have to flip the sign. 5x less than -20, we divide the 5. X is, did I divide by a negative number? Well, the number I'm dividing is the 5. The 5 is positive. I keep the sign the same. -20 divide 5 is -4. If I were to plot that, let's see, -4 One bigger is negative 3. One smaller is negative 5. And I don't include the 4, it's open circle. And less than means I go this direction. So any numbers less than negative 4 will work. Okay, on this one, notice that the x's are on different sides. So the first thing we need to do is get our x's on the same side of the street. So we're going to move this 3x over, minus it on both sides, 0, negative 4. I have not divided or multiplied by negative, so I keep my symbol. 7 minus 3 is 4x. And I need to get rid of the 4 and divide it out. So I have x. I bring down my symbol. I divided by a positive 4, if you notice that. And negative 4 divided positive 4 is a negative 1. Now, do you notice that x is on the wrong side? So I do actually have to flip this thing around so that the x comes first like it did on all the rest of them. Notice x is what you see first. So if I flip it, you flip the whole thing over. So x, I flip the sign. So the alligator is eating the x, and the alligator is still eating the x, and negative 1. So x is greater than or equal to negative 1. Okay, a few more practice ones. So I need to get rid of the negative 7 and the 9, so I would add 9 to both sides, just like I'm solving a regular equal sign problem. So negative 2 plus 9 is 7. Negative 7x. To get rid of negative 7, I divide it. And if you notice, I'm dividing a negative number. So my sign is going to flip, bring down the x. 7 over negative 7 is negative 1. And one more thing, this x is in the wrong spot. I have to flip the whole thing back over because the x is in the wrong spot. So first I flipped the sign because I divided by a negative. And the other reason I'm going to flip this over is because the x needs to be first. So I flip it back over. So x is less than negative 1. And you could check it. You could plug in a negative 2 and see if it works. So negative 2. I know negative 2 is less than negative 1, so I picked a number that's less, and I'm plugging it in for x in the original equation. And I'm going to inequality, and I'm going to see if this works. So this is 14. 14 minus 9. And let's see, 14 minus 9 is 5. So negative 2 is less than 5. Well, that's true. And so this really is correct. All right. Okay, I'm going to minus 1. Minus 1. There's 0. Negative 5x. Bring it down. I did not divide or multiply by a negative. I just subtracted. Well, 1 minus 1 is 0, so I got to put a 0 here. And I'm dividing by a negative 5. I'm dividing by a negative. That means I do have to flip my sign. 0 divided by anything is 0. So in this case, x is less than or equal to 0. So any numbers that are equal to 0, so if you were to plug in 0, that'll work. Plug in negative 1, negative 50, negative 2.5. Any numbers that are less than or equal to 0 will work in that inequality. So this is just a review. I'm going to go through this kind of fast. So we've got x is less than or equal to 4. I shaded in. It's equal to the 4. And it says less than. So any numbers that are smaller than 4 will be included. Right, the inequality, x. It's headed to smaller numbers, so those are less. And it's not equal to, and the number it's on is negative 3. X is less than negative 3. Solve this. I divide both sides by 6. X is less than negative 18 divided 6 is negative 3. Notice the number that I'm dividing is a positive. I did not flip the sign. And I could graph that. That's actually just the same graph that's right there if you were to put it on a number line. Solve the inequality.